According to the National Electrical Code, GFCI protection is required for all 120-volt, 15 and 20 amp receptacles located within 6 feet of the inside walls of a bathtub or shower stall. However, there is an exception for recessed lighting fixtures that are installed in a ceiling that is at least 8 feet above the top of the tub or shower. This means that if the recessed light is installed in a ceiling that is at least 8 feet above the top of the tub, then GFCI protection is not required. If it is not, then GFCI protection would be required. To determine if GFCI protection is required, measure the distance from the top of the tub to the ceiling where the recessed light is installed. If the distance is 8 feet or more, then GFCI protection is not required according to the National Electrical Code. If the distance is less than 8 feet, then GFCI protection is required by the National Electrical Code for the lighting circuit. It is important to note that local building codes may have additional requirements for lighting fixtures installed over bathtubs or showers. It is always a good idea to check with the local building department to ensure that all applicable codes are being followed. GFCI, which stands for Ground Fault Circuit Interrupter, is a safety device that protects against electrical shock. It works by monitoring the current flowing through a circuit. If it detects any imbalance, it quickly shuts off the power. This can happen if current is leaking to ground, for example, if someone touches a live wire while standing in water. GFCIs are commonly used in bathrooms, kitchens, and other areas where there is a risk of water exposure. They are typically installed in receptacles or circuit breakers. When selecting a GFCI device, consider the amperage rating. It should match the amperage of the circuit it is protecting. Also, consider the trip current, which is the amount of current leakage that will cause the GFCI to trip. A typical trip current is 5 milliamps. There are two main types of GFCIs, receptacle type and circuit breaker type. Receptacle type GFCIs are installed in place of standard receptacles. Circuit breaker type GFCIs are installed in the electrical panel. Both types provide the same level of protection. When installing a GFCI, follow the manufacturer's instructions carefully. Be sure to test the GFCI after installation to ensure that it is working properly. To test a GFCI receptacle, press the test button. The reset button should pop out indicating that the GFCI has tripped. Then press the reset button to restore power. To test a GFCI circuit breaker, press the test button on the breaker. The breaker should trip. Then reset the breaker to restore power. If a GFCI trips frequently, there may be a problem with the circuit. Check for loose wiring or damaged appliances. If you cannot find the problem, consult a qualified electrician. Proper wiring is essential for electrical safety. Always use the correct gauge wire for the circuit. Follow the National Electrical Code and local building codes when wiring. If you are not comfortable working with electricity, hire a qualified electrician. When working with electricity, always turn off the power at the circuit breaker. Use insulated tools and wear safety glasses. Never work on electrical equipment when you are wet or standing in water. Electrical safety is important to prevent electrical shock and fire. Always follow safe practices when working with electricity. Regular inspections of electrical systems can help identify potential problems. If you notice any signs of electrical problems, such as flickering lights or hot outlets, consult a qualified electrician. The National Electrical Code, or NEC, is a set of standards for electrical wiring and equipment in the United States. It is published by the National Fire Protection Association, or NFPA. The NEC is updated every 3 years. The purpose of the NEC is to ensure electrical safety. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. The NEC is not a law, but it is often adopted by state and local governments as part of their building codes. This means that compliance with the NEC is legally required in many areas. Electricians, contractors, and other professionals who work with electricity must be familiar with the NEC. It is a valuable resource for ensuring electrical safety. The NEC contains numerous articles and tables that provide detailed requirements for electrical installations. For example, Article 210 covers branch circuits, which are the circuits that supply power to outlets, lights, and appliances. Article 250 covers grounding and bonding, which are important for preventing electrical shock. Table 310.15b16 provides ampacity ratings for conductors, which are the maximum currents that conductors can safely carry. The NEC is a complex document, but it is essential for anyone who works with electricity. By following the NEC, you can help ensure electrical safety and prevent electrical accidents. Local building codes may have additional requirements that are not covered by the NEC. It is important to check with the local building department to ensure that all applicable codes are being followed. For example, some local codes may require the use of arc fault circuit interrupters, or of size in certain areas of the home. A size is similar to GFCIs, but they protect against arc faults, which are a common cause of electrical fires. Another example is that some local codes may have more stringent requirements for the installation of smoke detectors and carbon monoxide detectors. It is always a good idea to check with the local building department to ensure that you are following all applicable codes. The information provided here is for general guidance only and should not be considered a substitute for professional advice. Always consult a qualified electrician or building inspector for specific questions or concerns about electrical safety or building codes. Electrical work can be dangerous, and it is important to take all necessary precautions to prevent electrical shock and fire. By following safe practices and complying with all applicable codes, you can help ensure a safe and reliable electrical system. Always remember to turn off the power at the circuit breaker before working on any electrical equipment. Use insulated tools and wear safety glasses. Never work on electrical equipment when you are wet or standing in water. If you are not comfortable working with electricity, hire a qualified electrician. Regular inspections of electrical systems can help identify potential problems. If you notice any signs of electrical problems, such as flickering lights or hot outlets, consult a qualified electrician. Maintaining a safe electrical system is an ongoing process. By staying informed about electrical safety and following safe practices, you can help protect yourself and your family from electrical hazards. The National Electrical Code is a living document that is constantly being updated to reflect new technologies and best practices. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical system is in compliance. Many resources are available to help you learn more about the NEC. The NFPA offers training courses and publications on the NEC. There are also many online resources available, such as websites and forums. By taking the time to learn about the NEC, you can become a more informed and responsible user of electricity. Always prioritize safety when working with electricity. Electrical shock can be fatal. By following safe practices and complying with all applicable codes, you can help prevent electrical accidents. Remember to turn off the power at the circuit breaker before working on any electrical equipment. Use insulated tools and wear safety glasses. Never work on electrical equipment when you are wet or standing in water. And if you are not comfortable working with electricity, hire a qualified electrician.